Have you ever found yourself in this trap where you're trying to make the perfect choice instead of just a good one?
Oh, all the time.
Mm.
The classic example is scrolling through a streaming service.
Exactly. Last night, I spent 45 minutes looking for the absolute best movie to watch. I was so focused on maximizing my evening that I ended up watching nothing at all.
Right, and that little story perfectly sets up what we're talking about today. It's this idea from AI research called aspiration-based reinforcement learning.
Okay, so let's break that down. Most AI we hear about is like me with the movies, right? It's a maximizer.
Precisely. A standard RL agent is, for lack of a better word, greedy. It's programmed to find the absolute maximum reward in any situation. Every single point counts.
But this is different.
Completely different. It's based on a concept from Herbert Simon called satisficing. It's a mix of satisfying and sufficing.
So just being good enough.
Exactly. The agent has an internal benchmark, an aspiration level. It takes an action, and if the outcome meets that level, it's happy.
It stops searching, it finds something that works, and just sort of sticks with it, like a habit.
That's the mechanism.
Mhm.
It creates inertia. The agent only starts exploring again, only experiments if it gets a result that's below its aspiration level, when it becomes, dissatisfied.
But that level isn't fixed, is it? I remember reading in the Mukherjee paper that it can change.
You're exactly right. The aspirations adapt. It's almost like a hedonic treadmill
Yeah.
for an algorithm. If an agent is winning all the time, its standards go up. It needs more to feel satisfied.
And if it's constantly losing,
Its expectations might lower, so it's not in a constant state of disappointment.
right.
It learns to be content with less. It's just so much more like how we operate.
It really is. And, speaking of adapting to get the best results, this is probably a good moment to mention our sponsor, Silk.
Good call.
If you're a business trying to figure out where AI can make the biggest impact for you, they're the people to talk to. Silk specializes in AI training, automation, and integration.
So they can help you decide if you need a greedy maximizer or maybe something a little more subtle.
Right. You can check them out at embersilk.com. So getting back to the social side of this is where it gets really fascinating for me.
It's a huge leap because when you put those greedy maximizing agents together in a simulation, like the classic prisoner's dilemma, they often betray each other.
Of course, because the math tells them that in the short term, defecting gives the highest possible score.
But aspiration-based agents are different. They become what researchers call conditional cooperators.
Right. Meaning what? Exactly.
Well, they aren't trying to bankrupt their neighbor. They just want to get a result that meets their own aspiration level. So if cooperation gets them there,
They'll stick with it. They stabilize on a cooperative outcome because it's good enough for everyone.
and this isn't just theory. A really recent study from Kulkarni and Brunswicker in 2024 actually tested this.
Oh, this is the nudge experiment, right? This part is amazing.
It is. They put a group of these satisficing agents together and then introduced one special agent, a nudging agent.
And this nudger didn't force anyone to do anything. It just, led by example.
That's a great way to put it. It acted like a pace setter. It consistently made cooperative choices, contributing to a public good in the simulation, and in doing so, it signaled a social norm.
So it basically hacked the other agent's aspiration levels.
You got it. By seeing the nudger's consistent contribution, the other agent's internal benchmark for what counted as satisfactory performance went up. They had to cooperate more to feel good about their own choices.
And the results were pretty significant, weren't they?
They were. This one simple nudge increased the group's total contributions by over 8%, and the amount of cooperative behavior just shot up by somewhere around 12 to 14%.
Wow. All without any force or commands, just by understanding that the agents wanted to meet a standard.
It's a bridge between that rigid mathematical optimization and the messier world of social norms and human interaction.
So when we step back, the big takeaway here is that maybe the future of truly useful AI isn't about creating these ruthless, win-at-all-costs machines.
I think that's it. If we can design systems that understand the concept of satisfaction instead of just maximization, we might actually build digital communities, and even real ones, that value stability and harmony over pure cutthroat efficiency.
Maybe good enough really is the optimal strategy after all. Something to think about.
For sure.
If this deep dive sparked your curiosity, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in to Intellectually Curious.